Okay, so in our second video, what we're going to be looking at is converting the script that we made last time and making it into a function. Okay, so in lectures, we pretty much showed, I showed in a few slides that to make a function, all we need to do is add a function declaration at the first line. So to do that, we use the function keyword. We provide all the outputs that we want to have. So in this particular case, I don't want any outputs. Actually, no, I lie. I'm going to have two outputs. They're going to be the two roots, so R1 and R2. We're going to have those as an output. We put an equal sign. If we've got outputs, we need an equal sign. If we don't have outputs, we don't put the equal sign, and we're going to put the function name. Now, MATLAB standard practice is that the function name is the same as the file name. This is done because we want to easily be able to find these functions wherever we are, and so MATLAB actually searches for the file name, not for function names. So in this case, it was parabola that we named the script, so I'm going to name my function parabola. And it has open brackets and a set of inputs. Now the inputs that I'm going to have are going to be A, B, and C, because those are the three values that define a parabola. Okay, so there's a few warnings here. Let's just have a look at these. Best practice is to separate output variables with commas. Okay, so it wants us to put a comma there, and it fixes that. And it says here, input argument A might be unused. So straight away, that doesn't really say that much to us. But what's happening so far in our script is that one of the first things that we do is overwrite the values of A, B, and C. So I'm going to get rid of where we're overwriting these values, because we want to use them as an input to the function. Alright, so that warning has now gone away, and effectively we've written our first function. So I'm going to save this as is, and inside of my command window I'm going to call the function name and give it some inputs. So A was 1, B was 3, C was -5, and when we run this one, just dock this guy, you can see that we've gotten that figure that we had before, and it's also shown us one of our roots. Okay, so there's a couple of things that I'll go through in a second. So like I said, same as before, we got our figure, so that's fine, our code is working, it gave us the right answer. But it only gave us one of these roots where we wanted both of them. Now when a function has multiple outputs, so parabola in this case has two outputs, we actually have to store both of those when we call the function. So root 1 and root 2 are what I want to store them as. So we can name these whatever we want them to be, and that is equal to parabola 1, 3, -5. Alright, so doing this, we get our figure again, which is fine, and root 1 and root 2 now have the value of those roots. Okay, so just disregard this workspace. I'm going to clear it, so I didn't clear it before. So these are just residuals from the last time I ran it as a script. So if I type clear and do this previous line again, we can see that the only two values we have are root 1 and root 2. Alright, so fantastic. So I'm just going to make a slight change to my function here. I'm going to say hold off before I do the first plot. So that basically my screen recording stuff isn't working properly at the moment, and I have to keep docking this figure window. But now when I run this and change it, so change this one to say +5, I can just swap over to that window, no drama. But we've got an error message. So we're going to address some of these issues in a second, but we can see that we've got a imaginary root because there's no point where it's crossing the x-axis. Alright, so we have a function, and to demonstrate that we're working in our own workspace, I'm going to put a breakpoint in here somewhere, and I'm going to call the function again when we're giving it a decent set of values. So we've stopped at our breakpoint, and we can look in our workspace, and we can see that we've got all the variables that we had before. Alright, so all the variables that we had when it was a script, it's just in our own in its own workspace. Now we can't see root 1 and root 2, so they existed in the workspace beforehand, and when I press continue, it will finish this function and return me to the previous workspace. So this is just my base workspace, but inside of the function we've got our own workspace. Alright, so in this video so far we've demonstrated a couple of the big advantages of functions. It's very easy to change parameters that we want to change, so I can change this to -10. I've still got my breakpoint on, so we can see workspace once again. Continue that, have a look at our figure, and it's plotted that appropriately. It's given me the correct roots, so there's a root at -5 and a root at 2. And I didn't have to change my script at all, so I don't even have to have this open. I can just call this function. Okay, so that's a huge benefit of using functions. The other one is the workspaces. So it gets its own workspace. We can name variables whatever we want to, and as soon as this function has finished running, that workspace disappears. Okay, so everything that was inside of it, it gets cleared. Okay, so I'm going to stop this video here, and in the next video we're going to go on to a few other features of functions.